In 1950, physicist Enrico Fermi was having lunch with colleagues at Los Alamos when he asked a question that has haunted science ever since. They had been joking about flying saucers. Fermi did some rough math in his head, thought about the age and size of the universe, and then asked simply, "Where is everybody?" He was not being whimsical. The math genuinely does not work. Given the age of the universe, the number of stars, and the speed at which a single civilization could spread across a galaxy, we should not be alone. We should be drowning in evidence of others. We have found nothing, not one confirmed signal, not one probe, not one structure. 75 years of looking. Total silence. Here is why that silence is the problem. Actually Science. Episode 8. The Fermi Paradox. The misconception. Why people think the silence is normal. Most people assume the silence makes sense. Space is big. Civilizations are probably rare. Of course, we haven't heard anything. This intuition feels reasonable. It is also not what the math says. The Drake equation, developed by astronomer Frank Drake in 1961, estimates the number of civilizations in our galaxy capable of communication by multiplying a series of probabilities. The rate of star formation, the fraction of stars with planets, the fraction of those planets that could support life, the fraction where life actually develops, where intelligence develops, where technology develops, and how long such civilizations survive. Even with conservative estimates, for every single factor, the equation tends to produce numbers ranging from thousands to millions of potentially communicating civilizations in the Milky Way alone. And the Milky Way is one galaxy. Current estimates suggest there are more than 100 billion galaxies in the observable universe. The numbers are not the problem. The numbers suggest we should not be alone. The problem is the total absence of evidence. The ground floor. Why a civilization should be loud. Here is the part that makes the silence genuinely strange. You do not need a civilization to be common. You only need one to have started early. Consider the timescales involved. Stars capable of supporting rocky planets have existed for roughly 9 billion years. Our own civilization has existed, in any technological sense, for a few hundred years. If even one civilization in the galaxy's history developed space travel even 1 million years before us, a vanishingly small fraction of the 9 billion years available, they would have had enough time to colonize the entire galaxy. This is not speculation. It is basic orbital mechanics and exponential growth. Physicist Michael Hart calculated in 1975 that even at speeds far slower than light, self-replicating colonization could spread across the entire Milky Way in under 10 million years. 10 million years sounds long. Compared to the age of the galaxy, it is essentially instantaneous, less than 0.1% of the time available. This is sometimes called Hart's fact, and it is the real engine of the paradox. Not that civilizations are rare, that even a single early one should have filled the galaxy long before we arrived to look. The real concept, the proposed solutions. There are dozens of proposed solutions to the Fermi paradox. None has achieved consensus. A few deserve real attention. The Great Filter Hypothesis, proposed by economist Robin Hanson in 1998, suggests that somewhere along the path from simple chemistry to galaxy-spanning civilization, there is a barrier that almost nothing gets past. The unsettling question is whether that filter is behind us or ahead of us. If the filter is behind us, if the origin of life itself or the leap from single-celled to multicellular organisms is the rare, nearly impossible step, then we have already beaten the odds. We are rare, and we should expect to stay alone. If the filter is ahead of us, if it is something like nuclear weapons, engineered pandemics, or uncontrolled artificial intelligence, then every civilization that reaches our stage of development encounters it and does not survive. This is the more frightening version, because it implies something is coming for us too. Astronomer Robin Hansen and others have spent considerable effort trying to identify which past evolutionary steps were genuinely improbable, in an attempt to locate the filter. There is no consensus answer. A second major proposed solution is darker still. The dark forest hypothesis, popularized by science fiction author Liu Cixin, but grounded in real game theory, proposes that the universe is silent because broadcasting your existence is suicidal. The logic works like this. Any civilization advanced enough to detect you is potentially advanced enough to destroy you. And given the vast distances and times involved in interstellar contact, there is no way to verify the intentions of an unknown civilization before it is too late to react. The safest strategy, under uncertainty, is to stay silent and eliminate threats before they can respond. Every civilization that broadcasts loudly either gets eliminated or learns very quickly to stop. This is unsettling, but it is not science fiction speculation alone. It borrows directly from established game theory around uncertainty and preemption under conditions where verification is impossible. A third, less dramatic possibility is simply that we are looking in the wrong way. SETI has searched primarily for radio signals. An advanced civilization might communicate using methods we have not yet developed the technology to detect, or might have stopped using radio entirely, the same way humanity is already moving away from broadcasting radio and television signals into space. We may simply be looking for smoke signals in an age of fiber optic cable. The frontier, what we are still looking for. The search has not stopped. It has become more sophisticated. As of 2024, astronomers have confirmed more than 5,500 exoplanets, with thousands more candidates awaiting confirmation. The James Webb Space Telescope is now capable of analyzing the atmospheric composition of some of these distant worlds, searching for biosignatures, chemical signs that could indicate life. In 2023, a team led by Niku Madhusudan at Cambridge reported a possible detection of dimethyl sulfide in the atmosphere of K2 to 18b, a chemical that on Earth is produced almost exclusively by living organisms. The finding was preliminary and has not been confirmed with the statistical confidence required for a real claim, but it represents the kind of evidence that future observations might eventually provide. We do not know which solution to the Fermi Paradox is correct. We do not know if the great filter is behind us or ahead of us. We do not know if the universe is silent, dangerous, or simply speaking a language we have not yet learned to hear. What we do know is that the question Fermi asked over lunch in 1950 remains one of the most important unanswered questions in science. And the answer, whatever it turns out to be, will tell us something profound about our own future. One proposed answer deserves its own examination. The possibility that complex life itself requires a far rarer set of conditions than we assume. On Hard Truth Science, we look at that directly. Actually Science, Complex Science, Actually Explained. Follow us on YouTube at Actually Science, though.